So this is saying use left endpoint approximation methods. So that means we're supposed to take the left side of every interval and use that to dictate the height of the rectangle. We're supposed to get 4 of them on this interval. So let's find out how long this interval is. The largest value subtracted by the smallest value of that interval. That's 4 over 8 minus 1 over 4 over 8 pi minus 1 over 8 pi. So that's 3 over 8 pi. So that's how long that interval is, but I need to split it into 4 pieces. So if I divide that by 4, then I've got 3 pi over 8, 32. So that's how long each interval is supposed to be. This one's ugly, but you're supposed to take pi over 8 as a starting point, and then the ending point of the first interval should be plus 3 pi over 32 from it. So pi over 8. That's 4 pi over 32, and we're adding 3 pi over 32 to it. So this is 7 pi over 32 for our first subinterval. The second subinterval starts where the last one ended off. Then we're going to add another 3 pi over 32 to it. And I know I could simplify this, but let's just leave it. I'm adding 3 pi over 32 to it. That way I'll have common denominators for the next one. And then add another 3 pi over 2, so we got 13 pi over 32. And then add another 3 pi over, so that's 16 pi over 32. Oh, it's only 3 subintervals. What did I do wrong? Oh, I skipped over one. Look, this doesn't start where this ended off. Sorry, so there should be, I was getting ahead of myself. 10 pi over 32 to 13 pi over 32. And then the last subinterval is 13 pi over 32. And if you add another 3 pi over 32 to it, you get 16 pi over 32, which is just pi over 2, which is where we wanted to end in the first place. All right, so here's our 4 subintervals. Now the graph of cosine squared x, you don't necessarily need to know exactly what it looks like, but let's just say, I'd have to think about it to sketch it by hand. That's not one I've got memorized. It starts at the square. I think it might look like something like this. I'm not 100% sure. You could graph it too to sketch it yourself, but we're supposed to start at pi over 8, so somewhere around here for our first interval, and then it ends at 7 pi over 32. So this is a subinterval, but we're using left endpoint approximation method, which means I need to make my rectangle start on the left side. So this one's going to be over approximating the area if I sketch the graph correctly, right? Because it's got this, that's not part of the area under the curve. And then from 7 pi over 32 to the next one, you'd use the left endpoint approximation method. So we're plugging in these values to find out the heights of those rectangles into the function. So the y value is, here, well, let's use function notation, f of pi over 8. Excuse me. If I plug that in, cosine pi over 8 is what I need in radians. Pi over 8 cosine, and then I'm supposed to square that result. So carry out a bunch of decimals to make WebAssign happy. That is, remember, the height of the rectangle. That's the left part of the endpoint, the y value corresponding to the left part of our endpoint. And so the actual area of this rectangle is length times height. Okay, because it's 2 dimensional. So we need this times this. And this distance is the same for each one because they're all equal subintervals. Remember, this was that 3 pi over 32, the length of each interval that we just got. So I got to multiply that by 3 pi over 32. So this times 3 times pi, divide by 32. Okay, there's my first rectangle. And then for the next rectangle, we were using a left endpoint approximation. If we were using right endpoint approximations, we'd be just using this one over here. And if you're using middle approximation method, you'd just be plugging in the average between these two, the exact middle. So I need the y value, I need this value on our graph. So I need to do 7 times pi divide by 32, and then I need to plug that into my function in for x, so I need cosine, and then I'm going to square that result. And then while I'm here, I'm just going to calculate the entire area. Well, I wrote out the notation, so let me put that there. Okay, so the area of the second rectangle is that the height of that rectangle times the width, the 3 pi over 32. Okay, so for the next rectangle, this is what I got. Okay, so if we keep going in this fashion, the next one we need 10 pi divide by 32, put that in cosine, square the result, and then multiply that by the width, the 3, the pi over 32. There's our third rectangle. Fourth rectangle, I need to plug in 13 pi over 32 into my cosine function, square the result, and multiply that by 3 by pi divide by 32. Okay, add those up, and then you've got your approximation of the area under the curve using a right endpoint rectangular approximation method. Go ahead and impress your family by talking about that in the holidays. I know how to do a right endpoint rectangular approximation method. So I got 0.5431, that's the fourth decimal place, so I think that's what they wanted.